Hi guys, so today we're going to be talking about angle measures. Before we get started, I wanted to talk about some of our vocabulary words, okay? Specifically ray, opposite rays, and angles, okay? So a ray is part of a line. A ray has an endpoint, and then on the other side, it goes on forever and ever, okay? So this is ray AB. When you're naming a ray, you start with the endpoint, and then the second letter is, it isn't an endpoint because that would be a line segment. You just pick another point going towards that direction, okay? And then this is the symbol. Okay, so again, when you name a ray, you start with the endpoint and then another letter from the other direction that it's going forever in. Okay? Opposite rays, okay, are rays that form a line. They share an endpoint, and the reason why they're called opposite rays is because they go in opposite direction. Okay, so an example here is that ray RQ. Okay, again, you name it with the endpoint first, so ray RQ. So even though Q comes before R here, it's still called ray RQ because the endpoint is R. Okay, so ray RQ and ray RS are opposite rays. They're going in opposite directions and they form a line. Okay? And then the last one here is angle. Okay, an angle is consistent of two rays that share an endpoint as well. Okay, so you can see that this angle here is formed by ray YX as well as ray YZ. Okay, the two rays are known as the sides, and the endpoint in which they share is known as the vertex. Okay? When you name an angle, you either name it with 3 letters or 1 letter. The 3 letters, you name a point from one of the sides, the vertex is in the middle, and then you name a point on the other side, right? So that's why it's ray XYZ, or you can do ray ZYX. But note, the Y has to be in the middle because that is its vertex. Okay? In some cases, you can also name it just with its vertex. However, you can only do that if it's unambiguous, if there's no other potential angle Y's out there. Okay? In that case, then you can name it with just its vertex. Okay? So these are 3 ways to name this same angle here. Okay? So let's get started with example 1. So example 1 asks me to name all angles that have W as a vertex. Okay, so here's W as a vertex. Okay. So I'm going to name it here. So first one here, I have angle 1. Right. Angle 1 is here. I have angle 2 as well. That's here. I have angle 3 as well. Okay. I can also name it with its letters. So angle 1, another name for it is angle XWZ. Okay. I can name angle 3 as angle ZWY. I can name angle 2 as angle YWV. Okay. You can also do the reverse of that. So I could do also ZWX, YWZ, and VWY. Okay. I can also form an angle like this here, right, with both 1 and 3. So that one would be angle XWY, or the reverse order, YWX. Okay. And I can also name the angle with 3 and 2. So that would be ZWV, as well as its reverse if I wanted. Okay. And then I can also name an angle that consists of 1, 3, and 2. In that case, this would be a straight angle, and so that would be XWV or VWX. Or XWV or VWX. Okay. Technically, I didn't have to rename 1, 2, and 3 with their letters, and I didn't have to do the other ones since we know which ones we're talking about. Okay. Keep in mind, though, that none of these I labeled as angle W. The reason why is because that would be unclear about which one of these I'm talking about, because all of them has W as a vertex. Okay. So the next one is asking to name the sides of angle 1. So angle 1 is here. Okay. And so the sides is ray WX. Okay, again, starting with the endpoint, and ray WZ. Or I said Z, but wrote X. WZ. Okay. And then last one here, write another name for angle WYZ. So let's find that. So where is angle WYZ? So WYZ is W to the Y to the Z. So that's here. And this, you can either name it, since it's labeled with a 4 here, you can either name it angle 4, or, because in this case, Y only has this one angle, you can also name it as angle Y. Or, since this one WYZ, you can go reverse order ZYW. All of them are valid other names for this exact same angle. Okay. So here, why don't you check your understanding, not CYP, but check your understanding 1, 2, and 3, and then come check your answer. Okay, for number 1, vertex of angle 2 should be point C. The sides of angle 4 is ray BA, right? Because it starts at the endpoint, ray BA and ray BC. Okay? And then another name for angle BDC that's here is angle CDB. You can go the other direction, or angle 1. You, however, cannot call it angle D because that would be unclear whether we're talking about this, or a combination of some of them. The next part is measuring and classifying angles. You should be quite familiar with this, so this should be review. A right angle has a measure of 90 degrees, right? In geometry, we will only consider a right angle if we can prove it or measure it as 90 degrees, either because it has a symbol, something tells us that it's 90 degrees, but we can't just go based on how it looks, okay? So if you ever draw a right angle, please make sure that you draw the right angle symbol for it, okay? An acute angle has an angle measure between 0 and 90 degrees, right? Looks something like this, okay? And then an obtuse angle has a measure between 90 and 180. Okay? And looks like this. That's an obtuse angle. Okay. So what we're going to do with example 2 is we're going to measure each angle and classify it as right, acute, or obtuse. Okay. So what we're going to do first when we're measuring angles. So here we want to measure the angle PMQ. So let me highlight that here for us. Angle PMQ is this one. Okay. What we're going to do first is we're going to extend the sides. The reason why is because, as you can see here, it doesn't go all the way to the little tick marks. Okay, and in order to get the most accurate reading, it would help if we extend it. So I'm going to extend one of the sides here until hopefully, I know you can't quite do it in your book, so in your book, if possible, maybe copy it. Okay. So the first thing when you're measuring an angle is you're going to match the vertex to, sometimes there's a hole or a circle, or in this case, some have a cross on it. You're going to match it to here. Okay, so I'm going to match it to this middle part. Then you're going to match one of the sides to either the left side of your protractor or the right side of your protractor, depending how it's faced. So here I'm measuring it up with P. Okay? And then, since the way it's matching, it's pointing to the left side of my protractor, where this 0 is on top, I'm going to use my top side of my numbers. Okay? If it was pointing to my this side 0, then I would use my bottom numbers. Okay? So here it's pointing to the left, so I'll use the left side, the 0 here. And then, hold on, match it up. Okay, and then here, as I'm going, 10, 20, 30, 1, 2, 3, 4, 5. So here, this is 35 degrees. Okay. Note sometimes some protractors might be a little bit off, or somehow I might have adjusted it incorrectly because on theirs, their answer is 30. Sometimes some protractors are less accurate and stuff like that. So I'll look more at how close you are to the right answer. Let me grab another protractor to see what that one measures as. Okay, so here I have a bigger protractor. So doing the same thing, matching my circle here. Oh, so this one I also get 35. So I don't know how the book got 30, but let's see. Okay, so here's the one from the book. Okay, so let's match it up. On mine it also doesn't point at 30, so I don't know how they got 30. Because that's not what either of the protractors say. So I think the book made a mistake there because that is not accurate whatsoever. Okay. But that's how we measure an angle. Okay. 35, since it's less than 90, this is considered an acute angle. Okay. Let's try the next one. So this one is TMR. Okay. This one you don't have to measure it because it actually even gives you a symbol. Okay, but just to practice measuring them, we're going to do that. Okay, we're going to match our vertex of our angle to either the circle, dot, cross, whatever we have in the middle of our protractor. Okay, then we're going to match one of our sides to the line of our protractor. Okay, and then here we can see it is, since it's pointing to this side, I'm going to use the 0 starting on this side, which is my bottom, and then it goes to 90. So that's 90 degrees. Okay. This one was a little bit obvious, but there you go. So 90 degrees, and that is a right angle. Okay. You're going to try CYP2, measure angle QMT, and then you're going to classify it as right, acute, or obtuse. Okay. I got 145 degrees for my QMT. Again, matching it with M. Lining up the bottom with one of the sides, I got 145. The book, since theirs was a little bit off, they put it as 150. But either way, that would be an obtuse angle. Okay. The next part is on congruent angles. Okay. And so here in your congruent angles, just as segments that have the same measure are congruent, if angles have the same measure, they are congruent as well. Okay. And how we know that they are congruent is either by the written measure or here, arcs on the figure indicate which angles are congruent. So as you can see, angle NMP has this one arc here, and angle RMQ has that one arc. Those arcs indicate that they are congruent with each other. Okay. So with that, we are moving on to our last example before we get to our bonus constructions, and that is example 3. Okay. So example 3 here, a trellis is often used to provide a frame for vining plants. Some of the angles formed by the slats of the trellis are congruent angles. In the figure, angle ABC, which is this one here, and angle DBF, which is this one here, are congruent. Okay. This is the symbol for congruency. If measure of angle ABC, this one here, is 6x plus 2, and measure of angle DBF, this one right here, is 8x minus 14, we want to find the actual measurements of angle ABC and angle DBF. Okay, so let's get started. Okay. So based on the information, we know that angle ABC is congruent to angle DBF, okay? If they are congruent, that means the measure, so this little m in front of the angle stands for measure, the measure of angle ABC should be equal to the measure of angle DBF, okay? Measure of angle ABC, we know is 6x plus 2, so I can substitute that in. So 6x plus 2 equals, and the measure of angle DBF, we're told, is 8x minus 14, and I can substitute that in. Right? Now I can solve for x. So I'm going to move the x's to the same side. This gives me 2 equals 8 minus 6 is 2, so 2x minus 14. I'm going to move the minus 14 over by adding 14 to both sides. 2 plus 14 is 16 equals 2x. Running out of space, continuing up here. Right? I'm getting rid of the times 2 by dividing by 2. And so I know that x equals 8. Okay? However, it didn't ask me to find what x is. It asked me to find what ABC and DBF is. Okay? So I know the measure of angle ABC is 6x plus 2. Now that I know that x is 8, I can substitute it in. 6 times 8 is 48, and 48 plus 2 is 50. So the measure of angle ABC is 50 degrees. I automatically know that DBF should also be 50 since they are congruent. However, just to check my work to make sure my x equals 8 was correct, I'm going to plug it back in also. So measure of angle DBF is 8x minus 14. Again, if I did it correctly, I should be getting that 50 as well. Okay, so substitute 8 for x. 8 times 8 is 64. 64 minus 14 is 50 degrees, and so also measure of angle DBF is 50 degrees, which is correct because they are congruent. Okay? So I'm going to have you try CYP3 here, and then once you're done, you can come check the answer. Okay, you should have gotten 24 degrees. If you got that right, you can either move on to the bonus section on constructions or get started with homework. If you did it, here's your explanation. Okay? So we are told that angle JKL is congruent to angle MKN. If they are congruent, it means the measures should be the same. Okay? And so here I set the measures to be the same. Angle JKL has a measurement of 5x plus 4, so I substituted that in. Angle MKN has a measure of 3x plus 12, so I substituted that in. Then I solved for x. So I moved the x's to the same side by subtracting 3x. That gave me 2x plus 4 equals 12. I moved the plus 4 to the other side by subtracting 4, and that gave me 2x equals 8. And then I got rid of the times 2 by dividing 2 on both sides, and that gave me x equals 4. Okay. Then, since the question asked me to find the actual measurements of the two angles, I took that 4 and I plugged it in to each of their equations. So here I got 5 times 4 plus 4. So 5 times 4 is 20. 20 plus 4 is 24. Because they're congruent, I should know that the other one is 24 as well. But just to check my work and make sure that it actually equals 4, I plugged it into the MKN formula as well. So 3 times 4 is 12, and then 12 plus 12 is 24. And there you go. Okay. So you can now go to the construction section or start on your homework. Okay. So for this construction section, what we're going to be doing is we're going to be copying an angle. Okay. So what we're going to do first, okay, is we're going to draw a ray. Okay. So here, let me do it in another color. We're going to copy it. Okay. So I'm going to copy this one. So first, I'm going to just draw a ray. Okay. Then, what I'm going to do is I'm going to open my compass. Any amount will do. I'm really worried since my compass is moving around a lot, but hopefully it stays. Okay, and then from your vertex of that original angle, you're going to make an arc. Okay, and then from your new ray and that endpoint, you're going to leave your compass the same and make the same arc. Okay. Hopefully your compass is better than mine. It stayed the same. It did. Okay. So here you should see my two subtle arcs. Okay. This arc was made with the same measurement that was here. Okay. Then what you're going to do now is where your arc intersected your two sides, you're going to measure it using your compass. Oh, there's a shadow. You can't quite see it. Okay. It's quite bright outside. So here I'm going to adjust it to measure it. Okay, there you go. And then from there, I'm going to move to where my arc penetrated my ray. And I'm going to swing it over. Okay. And there, now I just need to connect my endpoint of my ray to that intersection. Okay. And now I've copied that ray exactly. Okay. So now I'm going to repeat it again. So again, we're going to start with drawing a ray somewhere. Okay, I've been drawing mine to look exactly like the original. It does not have to. Okay, but, here you go. So I'm going to draw mine here. Okay, that's where I'm going to copy it. Okay, and then again, starting at the end point of your original, you're just going to make an arc of any size. Okay, just make sure it crosses both sides of your angle. Leaving your compass the same, you're now going to move to the end point of the ray you drew, and you're going to make that same arc. Okay. So then you're going to go to where your arc intersected both your sides, and you're going to use your compass to measure it. So here it intersected on this side, and then it intersected on this side here. So I'm measuring it. Then I'm going to move my compass to this side where it intersected my ray and make an arc. And now all I have to do is connect my endpoint to the ray to that intersection. And there you go. I copied that angle. That's how you copy an angle. Okay. The next one here is on bisecting an angle. Okay. How you bisect an angle, the first thing you're going to do is you're going to make an arc that goes through both sides of your angle. So, okay, let me move my camera. Okay, so you're going to start at your vertex. You're going to open your compass. Any length will do as long as it crosses both sides of your angle. Okay, so here, cross it. Okay. Then, once I have that, leaving my compass the same, I'm going to go to those two intersections, and I'm going to make an arc. All right? And go to the other intersection, and then make an arc. Okay? And then, now all I have to do is connect the vertex to these two new intersections. Okay. And what I've done now is I've created an angle bisector, and this angle is congruent to this angle here. Okay. So let's try it again. So again, the first step you're going to do is open your compass to any amount. Is fine as long as it'll cross both sides of your angle. Okay. Starting at the vertex of your angle, you're going to make an arc. Okay. The best way I've done it is instead of moving the compass, I move the paper. It makes it the easiest. Okay. That way you don't have to worry about your compass being all wiggly and stuff. Okay. Then, leaving your compass the same, you're going to go to where your arc intersected your two sides of your angle, and you're going to make an arc from each side. Okay, so again, leaving your compass the same. If you move the compass, you change stuff. Right? There you go. Right? And then once you have that, all you need to do is connect your vertex to your two new intersections. Okay, and now you've bisected the angle. And again, this half is congruent to this half here. Okay, and that's it for today. Have a great rest of the day. Bye, guys.